Today in 5.4 lesson, we are learning how to make predictions using experimental probability. Scientists study data to make predictions. We can use probabilities to make predictions in our daily lives. So in example 1, it says, Danae found that the experimental probability of her making a bullseye when throwing darts is 2/10 or 20%. So out of 75 throws, about how many bullseyes could she predict that she would make? So we're looking for about how many bullseyes she can make. We're trying to make that prediction. So you can use, there's two different methods you could use. We're going to go over both of them. In method number 1, it says to use a proportion. You should know by now that when you're setting up a proportion, it's very helpful to use your words. So we're going to use the words made and throws. So she made 2 out of 10 throws. Okay, so if she makes 75 throws, the 75 goes on bottom because it's the total, and you're trying to figure out of 75, how many will she make. So you're going to cross multiply here. 10 times x is 10x. 75 times 2 is 150. We want to find out what x is, so we divide by 10. Whatever we do to one side, we do to the other side. X is going to equal 15 bullseyes made, or we could say throws. In method number 2, it says to use a percent equation. This is where you would be finding 20% of 75. And remember that word of means to multiply, so you would have to change your 20% to a decimal, and you would just multiply 75 times 0.20. So 0, 0, skip a space, 10, that's 15, 0, 0, 5, 1. Remember, this has no decimals. The second number has 2, so total we have 2. So if I move it over 1, 2, notice I get the same answer. Okay, 15 bullseye throws. You can use either method, whichever one you like better. So you are going to practice what we just went over in the your turn. I want you to read the problem and choose one of those methods and show all your work. Pause your video. All right. On the your turn, it says that a car rental company sells accident insurance to 24% of its customers. So out of 550 customers, they want to know about how many customers would be predicted to purchase the insurance. So you could have used whichever method. I'm going to just do the percent equation, which means I change 24% to a decimal, move it over 1, 2 to the left, and I'm just going to multiply 550 times 0.24. That's 0, 20, 22, skip a space, 0, 10, 11, 0, 0, 2, 3, 1. We have 2 decimals in our problem total, so 1, 2. You should have got 132 customers. Be sure to label because it's a word problem. On the next section, we're using experimental probability to make a qualitative prediction. A prediction is something you reasonably expect to happen in the future. So qualitative prediction helps you decide which situation is more likely in general. So in example 2, it says, a doctor's office records data and conclude that on average, 11% of patients call to reschedule. So the office manager predicts that 23 appointments will be rescheduled out of 240 appointments during the next week. So it wants you to explain whether the prediction is reasonable. Okay, we're going to go ahead and use our 2 methods again. When we use the proportion, you could say the words reschedule over, you could put total appointments, or I'm just going to put a shortened appointment abbreviation. So 11 out of, since it's a percent, it's going to be 11 out of 100. And we're trying to figure out, well, how many will reschedule out of a total of 240 appointments next week? So again, I'm going to have to cross multiply here. 100 times x is 100x. 240 times 11, you could go over here and do your math. 1 times 0 is 0, 1 times 4 is 4. That's 2, skip a space, 0, 4, 2, 0, 4, 6, 2. So that is going to be 2,640. When you divide both sides by 100, I know that whenever I divide by 100, really you're just moving the decimal twice to the left. So that would be 26.4, and that would be customers that would reschedule those appointments or patients. So that's one way. The other way is to find 11% of 240. Again, remember that of means to multiply. You're going to have to make the 11 a decimal, move it twice to the left. So 240 times 0.11, that would be 0, 4, 2, skip a space. That would be 0, 4, 2 again, 0, 4, 6, 2. Again, no decimals on my top number, 2 decimals on my bottom. That's 2 total. Move it over 1, 2. Again, I got the same answer. Okay, 26.4 patients would be predicted to reschedule. In the reflection, it's asking, does 26.4 make sense for the number of patients? And it's asking you to explain. Well, you know that there cannot be 26.4 patients, but it is pretty close to the 23 that they had predicted. So you would just say, since there cannot be 26.4 patients, round to the nearest whole. So it would be about 26 patients, which is reasonable according to their prediction of 23. On the your turn, you're going to practice doing that same thing. Okay? You can use whichever method you want. You don't have to use both. So press pause. All right, let's see how you did on that one. He lost his sign. It says, in the emails to monthly readers of newsletters, 3% of the emails come back undelivered. So that's 3% of the emails come back undelivered. The editor predicts that if he sends out 12,372 emails, that he will receive 437 notices for undelivered email. Do you agree? So, again, you could have used whichever method you wanted. I'm going to go ahead and use the 3% of 12,372. Make this a decimal. Remember, you'd have to include a 0 in there because you have to move it twice to the left. So you should have multiplied 12,372 by 0.03. That is 6, 21, 11, 7, 3. So when you move it over twice for the amount of decimals in your problem, 1, 2, that's about 371 emails. Again, I rounded to the nearest whole. And 437 was the original prediction. So it's asking, do you agree? You should say no. It's about 371 emails undelivered. So the prediction was too high. Okay, on the back of your notes, flip it over. It's talking about making a quantitative prediction, okay, and we can use proportional reasoning to make quantitative predictions and compare options in the real world situations. So for example 3, it's talking about an online poll for a movie site, and it's showing the poll results right here. It says that it surveyed 150 people, and it asked them, they're leaving the movie and they're asking them how many of them liked the movie. Is the movie site's claim accurate if the newspaper finds that 104 people say they liked the movie? So it's asking if this site is accurate. Okay, when you are doing problem solving, this just shows you the steps you should be taking. It says that first you should analyze your information. Okay, so you're trying to always ask yourself, what are they asking me to find? Okay, and what information in that problem is going to help me arrive at that answer? So it's asking you, okay, the answer is going to be a prediction of how many people out of 150 will like the movie, okay, based on this online poll. And they also want you to tell whether the 104 people that say they like the movie is enough to support the movie site's claim. Okay, so is that claim accurate? The important information that you're pulling out of that problem, you have to look at this online movie poll. It says that 72% said yes. Okay, so that's important, that 72% say they liked the movie in that poll. And it's also important to note that they asked 150 people leaving that movie. So you have to formulate a plan. How am I going to answer this? You are going to use a proportion and calculate 72% of the people surveyed, okay? You don't have to use a proportion. I'm actually just going to change this to a decimal, and I'm going to multiply to find my 72% of 150. Please skip a space. 0, 9. Okay, so 0, 0, that's an 8, 0, and a 1. Again, I have 2 decimal places total, so if I move over 1, 2, that's 108 people, okay, that liked the movie. So remember that they had predicted 104, so you're justifying your answer at 108. Well, notice that that is pretty close. So you would say, since 108 is close to 104, the movie site's claim is accurate. On the your turn, okay, you're doing the same thing, and you're trying to see if you agree with your findings. So pause your video. Okay, let's read this example together. Let's see how you did. It's on average, 24% of customers who buy shoes in a particular store, they say that they usually buy 2 or more pairs. One weekend, 350 customers purchased shoes, and how many can be predicted? That's the first thing you're going to answer. How many can you predict would buy 2 or more? So if 107 customers end up buying more than 2 pairs, they want to know, was that more customers than normal? Okay, so you have to figure that out. You could have used the proportion or the percent equation. I'm going to go ahead and use that percent equation. Just seems faster. So 0, 20, 14, skip a space. That's 7. And I'm going to move my 2 decimal places in. You should have got 84 customers. So that's how many can be predicted. So actually 107 people ended up buying 2 or more pairs, and the question was, did more than normal customers buy 2 or more pairs? So the question would be yes. And you could say because 107 is greater than 84, more customers than normal purchased 2 or more pairs. Okay, so that is what we are going to be practicing again tomorrow in class. And again, let us know if you have any questions. See you tomorrow.